supposedly pays you 1 Bitcoin, right? Now, if I'm the attacker, do you think I have an incentive to create a fake block just to defraud you for 1 Bitcoin? All right, so I'll agree. Now, can you think of a way for me, the attacker, to make it financially viable to do something like that for people?
You can put 26 of these messages in your block.
Yeah. And the problem is, as an SPV node, well, you don't know how many of these messages actually are in the block. You only have 1. There could be 100 other fake transactions. And that's ultimately, I mean, you're trusting people, to be honest. And it's just not clear, like, at what point does this become a bad assumption? On the other hand, if it's a full node, I mean, I could still go and do a double spend. I mean, I could start with, say, 100 Bitcoins, create an invalid block, or, well, sorry, create a valid block that gives you all, you know, gives 26 people 1 Bitcoin. And then I could hopefully try to get another block that double spends it. So, I know it's not really clear what the security model is there either, but presumably, I mean, you know, this is frankly is like a big avenue of debate in the Bitcoin world. You know, if you make your assumption that your attacker doesn't have access to too much hashing power, and you try to force people to verify the rules, hopefully no attacker can construct a scenario where they earn money doing this. But I mean, you guys are a bit confused here as to why that's true. Well, don't worry, we are too. Right? It's not actually clear that a lot of this stuff's actually secure, depending on how your assumptions work.
But how is the full node actually checking the inputs? Because you have a hash and a signature, and how do they look it up?
So this goes back to your UTXO set.
Yeah, so you look the hash up?
Yeah, so your UTXO set's this big table.
Yeah.
All right.
Hash. You should take the bottom
Number. So script.
Your bottle should.
Yeah. So this number corresponds to the hash.
Mm-hmm.
I forgot to mention it's also the index number, like, you know, this is 0, this is 1, and so on. And you've got that thing. You got the script, hook key. You check it against the signature, and then you know what the value is. So that's, you know, that's your UTXO set. And as you verify transactions, you go through the UTXO set, you know, cross out stuff that's spent, and add new stuff to the bottom. Pretty much all there is to it. And the faster this is, the faster you can process a block.
This is like a thin client model, and
so if you have the UTXO set, right, that's the pruned node. You know, it's not thin in the sense that it's less secure, it's just discarded historical data.
and then you need to have the transaction time and the both of that. Do you think this problem is solvable, or that we need something in between, like a credits function?
Sorry, I'm not sure what you meant there.
Well, in the real world with transactions, you have different payment systems. One of them is like we had chip knip, prepaid, or have a credit system. And now we try to put the function in the blockchain for everything. Do you think that's feasible in the future, or that there needs to be a function in between?
Well, I think if you're talking about this versus accounts and so on, I mean, I think you make a good argument that all these other ways of doing accounting end up being representable by this kind of system, this transaction outputs. As an example, I mean, I can define an account to be, go through this set and just add up every output that has the same script hook key. And that is just the representation of my account. Whereas under the hood, I mean, even if you try to keep an account balances, or like get a list of account balances, as it turns out, to make such systems work, you have to have transactions. And once you have transactions, you might as well implement this type of system rather than bolting one transaction on top of an account balance. And the reason for that comes down to like how the crypto works, which has been involved, but essentially, any action on an account, you don't want that action to be possible to perform twice. Like if I go sign a check, right? If the check didn't have a sequence number, in a cryptographic system, I could take that data and resubmit it. Everything would still be valid, right? From balance is true, valid, the person sending it is valid, the sequence is valid. And if it's all valid, how do I know that I have to reject the second check, even the first one? Because the first one went through. It's very easy to unspent transaction system because every hash is unique. That's a guarantee in Bitcoin. Whereas in a balance-based system, you need a separate mechanism to guarantee that. Ripple is an example that does this, and they use they're called I think it's transaction or account sequence. Yeah, account sequence numbers, and like every time a transaction is posted to an account, the sequence number increments. Well, by the time you have that, I mean that's the sequence number too. It's that's the current state of a balance. I mean they're the same system. It's just one is more complex than the other. And all the complexities and the stuff where if you get it wrong, the whole system falls apart, right? Whereas in this model, if you want to extract the balance from that, if you or I do it somewhat different ways, that's okay. The underlying consensus system doesn't break.
Ripple is centralized, isn't it?
Well, that's an interesting question. Ripple. The way Ripple works is, and Ripple doesn't make it very easy to find this out, but it does have a blockchain under the hood. It's a series of blocks and blocks of transactions, and the transactions move money from one account to another. Now, Ripple says that they have validators in the system, and everyone can pick different validators. But if I have a different set of validators than you do, the validators I trust can come to a different state of consensus than ones you trust. And if that's true, well, you might go send me a token representing a house, and I'll think it's valid, and you'll think it's valid, but you think you got the house, and I think I got the house. This is really bad and creates incredibly strong incentives for people using Ripple to all use the same validators. So yeah, I mean, in theory, it's not centralized. Anyone can use their own set of validators, but you'd be crazy to just use the Ripple ones. So, I mean, Ripple people say it's decentralized, but I'd say that social incentives are so strong that it's centralized. Whereas in Bitcoin mining, because the definition of validity is about total work, anyone can participate in that. Anyone can contribute to the consensus. You don't need prior permission. And there's no reason for you or I to contribute to a different consensus because the rules very strongly encourage us to work together. On that basis, let's say it's decentralized. But
if you by chance had any time to look at the big chain DB?
Yeah.
yeah, I did, and it wasn't really clear to me what the heck they were actually doing.
And they're using a non-ACID database to scale to chip.
Yeah, I don't understand what they think they're really doing there, because I mean, maybe at like a high level. So something that's very easy in all these systems, right, with very high scale, is to do timestamping, right? And all the times, I mean, sometimes here this is called proof of existence, but timestamping is the more traditional term. And timestamping just means I have data, and I prove that data existed prior to a certain time. Doing this is really easy in blockchains, well, because that has a date attached, and it does for the retargeting mechanism to work. Well, anything here, if I follow back, the series of hash commitments, I know that if this date is valid, anything under here must have been created prior to the date. And the key thing with that is, I suppose that's our local treated timestamp data. All right, and I'll say this is January 1st. Right at millennia. Now, if I know that this was created prior to that date, I know that this was created prior to that date, and I'll say this is right. So I know the document representing the sale of my house was created that date. That sounds very good. Of course, equally, I can create a slightly different version of this. All right, house sale to Alice. House sale to Bob. And both documents were created prior to that date, but for the purpose of like registering the sale of the house, that's actually pretty useless. Alice and Bob care very deeply about whether or not there exists another document. They don't really care that much about when it was created. That's often not the case. I mean, if you want to prove, for instance, like an example is in a medical study, you might want to go prove that data was generated prior to other data being generated, because first it said data might be something I can go fraudulently change, right, to correspond to separate research results. Maybe I'm determining like what's the association between this drug and cancer outcomes. Well, I might collect all that data and then do the processing later. And I want to be sure, as the data is collected, like I haven't changed it, because I will change it based on the outcome of other trials. In that case, timestamping is great, but if there exists a slightly different version of data, that's irrelevant, right? It just means like someone inputted in the wrong figure potentially. But that's not true in many cases, and I think big chain DB, if I understand what they're doing, they're much more focused. What they're really doing is more focused on the timestamping, not as clearly focused on, like the consensus side of stuff. And it'd be interesting to see if any of these systems get deployed, like how are they broken?
Is there some slack in timestamping for clients and miners, and how is that solved in the order?
Well, in Bitcoin, the rule is when your node receives a block, it will accept a block provided that the timestamp is less than 2 hours ahead of what you think the current time is. And that's your slack. And it's a little dodgy, but essentially if you're a miner, your incentive is to go create a block that, most people are going to accept as valid. Well, sort of an incentive. There's edge cases here, but that's the basic idea. And I could create a block with a timestamp in advance, but most of the network will go reject it. The problem is in many cases as a miner, it's actually my incentive to create blocks that people will reject. Because if I'm a miner and I get my blocks, say 95% of the hashing power, and the 5% rejected, those 5% lose out. And their blocks, the work they do on their blocks will just get orphaned by everyone else, because it's much more likely for the 95% to find the next block than they will. And if I get rid of 5% of my competitors, now I'm making 5% more money, right? Because the difficulty readjusts, and I'm doing less work for the same amount of money. But we don't really have good solutions to that. I mean, at least in that case, what will really happen is if people start playing with timestamps, The 5% miners will not reject blocks, right, outside of that window. And they'll just realize, well, these guys are just trying to screw me over, so I'll build blocks as well. But well, to be frank, we don't have good solutions to this. It's probably one of the most dodgy parts of the entire Bitcoin protocol, the dependence on current time. And we have to have it because otherwise you can't do the difficulty adjustment. But nobody really knows how to do this better.
Could you elaborate a bit more on these 2 hours window? What is that? Is that from the current time up in the future? Or?
Well, remember, there's no such thing as the current time, right? It's the local current time.
Yeah.
But your node will have a slightly different current time than my node will.
Mm-hmm.
And because of that, at the edge, some things might get rejected by some nodes, but not by others. If everyone creates blocks, within what they think the current time is, and nobody is out more by 2 hours in the forward direction, everything works fine. Now, in the other direction, so suppose I give you a block that has a timestamp 5 hours in the past. That rule does not reject that block. And the reason why that's okay is because backdating the timestamps on your blocks only makes the difficulty go up, which is not in your incentive as a miner. You want to forward date the difficulty to make the difficulty go down. You want to forward date the timestamps on your block to make the difficulty go down. Because it looks like more blocks were created, the blocks that were created in more time. Whereas in the reverse direction, blocks were created faster doesn't help you. Now there's an additional rule which says that the timestamp of a block must be at least 1 second in advance of the median time of the past 11 blocks. So it's like you take the 11, you take the median time of that, and you force blocks to advance that. And that rule will prevent, in reality, would prevent me in most cases backdating my blocks a long way back. But that rule isn't that important. And in theory, the way you could do it is you just say that blocks aren't allowed to have a timestamp less than the previous block. You don't actually need an averaging thing, which Pierce Satoshi didn't realize, but it's kind of nice to have some kind of rough rolling average of current time. But we honestly, as protocol designers, we honestly don't know how to handle this better. And it's just trying to get the real world into these systems is just so hard because, what is the real world? Like, how do you go get something as nebulous as time into a mathematical program? Your only link to the real world is people making claims via hashing power. So, kind of unfortunate there's this potential issue with forward dating, but at least it's not a major attack. I think if you wanted to do a timestamp proof, the easiest thing to just say is, well, whatever this time is at the top of your block, that's probably accurate within a day. It'll be roughly right. If you're trying to do like sub-second timestamping on Bitcoin, you're going to be in a world of trouble. But certainly it's within a day. It's, I think, pretty justifiable.
So we are ready. We can go on now. No questions anymore. No.
Just
I think people's brains are a bit fried.
Yeah. Okay.
you have to calculate the hash first.
Okay. Proof of work.
When do you guys want to break for lunch?
It's now over now, so we can prepare it out. You hungry? Hungry?
Fine by me.
I don't know what the agenda for.
Yeah, we don't have a very clear agenda. I announced that it would be during office times, but
Yeah.
Our oversight.
Yeah, yeah. I was already wondering with your office staff.
Yeah.
But I mean,
Yeah, now we can prepare it now and we'll be finished in half an hour.
okay. So yeah, then you know, we'll move on for half an hour and then.
Yeah, okay, cool. Yeah.
So I don't know if any of you guys want to, but you've got a copy of Python. We could even do some kind of bit hands-on with Python Bitcoin. Let's go through that. That's easier, a smaller group, but
You just do the hello world of a bit.
yeah, yeah, we can go through that.
Yeah, that sounds
Anyone have a copy of Ubuntu handy?
What?
Ubuntu, Linux distribution.
Just passing the
Ik best wel even, ja, waarvoor?
for Peter.
Oh, yeah, yeah.
So let me through.
I do it on my laptop too, but
Is Fedora okay as well?
Is Fedora okay?
I mean, I can do it on my laptop as well. Just figured if someone wanted to actually go through that, it would be worth doing in a group of 2 or 3.
The only thing is you might want to use this big screen if, depending on what you want to do. But
I missed a little bit of the conversation, so I will.
I was just saying, I mean, if some people are interested, we could go through like a bit of a, do it to show.
More hands-on.
Yeah.
Okay, yeah, but I mean, if you already have a laptop, that's also okay. You can use this one. This is
Yeah,
with Fedora.
well,
This one is from 2001, so.
I've never managed to get my laptop connected to a projector.
Oh, yeah, it's always a horror. It's the same with printers. But then.
is it useful a big screen or because it's?
I mean, it depends on who wants to go and look at it.
Do you have HDMI?
I do, but it doesn't seem to work.
Yeah. It's a nice one cable, so you can still set up there if you want.
So you have a laptop from the future with HDMI. So,
Bas, moet je even op tv daar de afstand doen.
Moet ik even jou geven?
Ja, gaan we er even op drukken. Ja, dat is zoals jullie staan.
Okay.
Is het heel mooi?
Yeah, I think that's it.
Maar dan, ja, als niet. Nee, nu neem je het niet op wat hij doet. Maar dat zou dan anders op mijn laptop moeten.
Ja, dat is ook wel.
Maar dan on your keyboard filming, Peter?
I guess. I guess you can just start if you without screen share. So most people can still follow me.
Yeah. Tricky. But I was thinking,
Maybe through the chat thing. Because there's the website chat.bitcoinference.com, and then you can at least copy paste some links and stuff for people.
So it's our web address with chat before.
Chat.bitconference.com.
Yeah.
So if everyone joins up, then Peter can just copy paste the URL or whatever.
The creator of the chat is just coming in, as far as if I'm right.
I just see M&M events, job international conferences, exhibitions in metals, minerals, and mining.
That sounds like the right one.
Sorry?
Bitcoin, for instance. Like Bitcoin, for instance.
Nice name.
Yeah, it's a good name, yeah.
Yeah, I thought of it already in 2010, 2011. I kept it in my mind for a year. I tend to postpone. And then I registered in 2012 or something.
Yeah.
But I was also surprised that nobody. But then again, until 2013, no one was looking at Bitcoin.
Yeah.
So, I mean, it was until 2013. It was the uber nerd of nerds.
Yeah.
Who was doing something like it. So.
We have a Discord board.
Ah, cool.
Don't know how it works.
Like I say, I've never seen this thing work, but I might get lucky.
It might be great. Misschien moet je weer een signaal achter. Oh ja, ja. Oh, ja. Ik zie je vol vertrouwen dat ik wil.
Yeah, I don't think that's working. Should be plugged in, but.
Maybe you need to change some screen properties or whatever.
No.
No. This one should just work.
We moeten letten, gewoon een klikje op.
Ja.
Kan wel.
Dacht ik ook, ja.
Maar die heb ik niet bij.
Ik ga even zien.
De oren aan te steken. Maar als je een paar naadjes doet.
Ja, dat is gewoon.
Yeah, I think this is hopeless.
Yeah, no. Okay, well, I guess we can do it without the big screen. But...
We hebben nog even lang tegen jaar.
Okay. Yeah.
So maybe I want to show this. Maybe the thing to do is, I mean, sure, not everyone wants to like follow through exactly for Python Bitcoin liquidity. When it does, come over here and I'll show you just directly on my screen. Probably the easy way to do it. Because I know like some people I think sounded more, interested in actually seeing this like directly in action. So it'd be a good thing to do.
You just watch over your shoulder.
Yeah, exactly. Yeah, that might be the easiest way to do it.
I think Jaap is getting a VJ cable. Maybe we can try.
Yeah, I've never seen a VJ work either.
Oh, okay.
I have a suspicion that the ports on this laptop are just broken.
Oh, really? Okay.
Yeah. I've never seen them work, but.
For some reason, I see that a lot. We have a lot of ports, SD card ports not working. And
I mean, I got this laptop used, so I got it at this disturbingly cheap price.
Yeah, you got it from Pindar. But you are also running on second-hand hardware.
Yeah.
Yeah, me too.
Yeah.
it's kind of a principle. This was my first-hand hardware.
Yeah. Yeah, all my phones have been bought new, but I've never bought a laptop new.
Yeah, yeah. I mean, yeah. But by the way, that is also why I started thinking differently about the Turing complete programming story, because I mean, computers are already doing 99% of the time nothing.
Yeah.
And so, I mean, let's say the objections against, let's say, a world computer, or how you would call it, are at this moment mainly technical. And I mean, they are in itself, I understand the objections, but I mean, you know, there are the whole IT world is filled with technically not very good design, but something which is developed because people just wanted it. And what I liked about the story of Ian was that, I mean, you know about the reproducible builds, the Git building.
Yeah.
And what I liked, because that actually made me change because I realized that, I mean, if you could have something like a trustless cloud, and if your services would be independent of your own hardware, because now you have your own hardware because you trust more your own hardware than other one's hardware. But if you could change that, I mean, it could be a very interesting idea, at least.
No VGA.
Too modern. Okay. Beamer. We have an old and loud Beamer.
Yeah. Well, if you think it's not going to work anyway with that port, then we'll just go for plan B, I guess.
Yeah.
Plan B is just looking over his shoulder.
Yeah.
Okay.
It works.
If you don't have too big of a shoulders, then I think. Would it be possible to put the webcam in, to somehow get the webcam also, or is it difficult? It doesn't make a lot of sense.
It's too blurry, I think.
Okay.
Too much.
The text on my screen isn't exactly
Yeah.
large already.
Yeah.
So,
Could we just
yeah,
stand around?
yeah.
Yeah, just stand around.
I'll just go show you guys like what's the basic setup looks like. Play with something. So. So I mean,
Yeah.
I think your big prerequisite is, I mean, you gotta know how, you gotta be able to use Git. Can you guys actually read that?
No.
Let me increase the font size on this.
What kind of EDI do you use?
Let's see. Increase. I think I moved here. I should double it. There you go. Yeah, no, this is QOS OS actually, which is basically gives you like different virtual machines for every purpose. So you know, like whatever I have in say my accounts can't access my work development or my work Bitcoin stuff or my mail. So much more secure. Essentially, your prerequisite is I usually get Bitcoin from a source. Yeah, so that's just GitHub. Yeah, and you can go off to GitHub and just download it directly. And just be clone. All right, now I'd go run that. And then within Git, I usually just compile the stuff from source and run it.
Now you have a local version of.
Yeah, so like I've got Bitcoin D running. There's one in debug mode. That one's also something called rake test. And the rake test is nice because it's just kind of like a blockchain you create for the sole purpose of doing local testing.
Mhm.
What's nice about that is, so I can go and under the hood, what's happening there is, so that's an alias I have, just set user with Bitcoin CLI-testnet. Bitcoin CLI is your interface to the Bitcoin RPC. Well, testnet are the same. You use the testnet ports. Rate test is the same. I do that. Oh, right. That's all my commands that I can tell my local Bitcoin node. You know, things like related to blockchain. I can get its current block hash. I guess the block. I get info about the blockchain. How many blocks there are.
Yeah.
You know, it's a big long list of stuff. Stuff related to creating transactions, getting information about the network, some mining stuff.
So that will be a good step up, just to download
Yeah.
the clone.
Yeah, and just play, compile with it, play with it.
Is there a place where, for example, in wiki where this is described, where you can
No, not really. The main mainly with this stuff, go to the doc directory and read. In this case, that's your overall directory for documentation.
No.
Here's your README for Bitcoin Core, setup, running,
I see.
files. There's specific notes per build platform. For Unix, build Unix. That goes through, what you need for your dependencies.
He's the creator of the chat, by the way.
Are you using it?
Yeah. Your APT commands to run. Like all that stuff, build essentially things that are essentially building anything. There's some more stuff you need for boost and so on. Yeah.
Okay.
There you go. All right, finally, the build example. AutoGen makes some files for configure command and make, as usual, the thing you can make it all. And just run it out of source. If that's actual Bitcoin gaming that you run. So when I ran it, that was me running it literally like this. Run it in debug mode, put in the background, and then that just means that that subcommand goes away. So when I close my terminal, Bitcoin doesn't stop. Yeah, and this being the rake test chain, right, which I create from scratch. There's only 165 blocks in it. What's nice about rake test is I create a block. All right, generate one block. Done. Now there's 166 blocks. Very easy to go test with. The way the interfaces with Python Bitcoin live is, let's look at their examples. So in here, once again, you download off GitHub, git clone, examples, and that timestamp something that publishes text. That's imports bootstrap file that can send a message. But these are probably the main ones. Like they can spend page of key hash and spend page of script hash transaction output. This just means spending your standard one whatever address. This is a P2SH output. So what does it actually do under the hood? Right. I should make this one a little simpler. For timestamping, here's a good example using Bitcoin with its own wallet. There's Bitcoin Core, of course, it has a wallet, so you can do useful things like say, get a new address. That'll get a new address on the rake test chain. Similarly on mainnet, we're familiar. I can go send money, send one fake Bitcoin. And list like unspent outputs. I might always watch myself, so I've quite a few fake Bitcoins there. And also, I can also go say, all right, what else can I do with list unspent? Well, it turns out there's a minimum confirmation, max confirmation. I want to say list unspent things with 0 confirmations to 10. All right, that'd be the one Bitcoin I just sent. That'd be some change. And that's another transaction I already did earlier. So for something like a timestamping thing, well, so this command, example, timestamping a file. And all these things, they tend to all start with get an RPC proxy. Yeah, so that's the RPC, the one I mentioned earlier with like HTTP between your program and your local Bitcoin instance. This this function, the Bitcoin RPC, you'll see it in one documentation. Essentially, that just does all the stuff behind the scenes connected to Bitcoin D. It knows what password to use. Based on your local Bitcoin comp, RPC user, RPC password. If you set that, that's just the way you can log in. There's some other stuff there, but these are the important ones that set.
Now it's all local.
Yeah, now it's all local. So this part's just getting digests, right? And yeah, like hash is something with Python Bitcoin load to just hash data. FD read, well, I'm just reading that file descriptor, right? Because I open that file, read it, hash the data, to my digests. Follow it down. This is just a thing. So, if I can just timestamp a hash directly. And all it's doing here is, well, for each digest, font in unspent transaction output in my wallet. That's a bit of Python stuff, but essentially, list unspent transaction with at least 0 confirmations. That data structure, right, has out points. Get some TX ins and create a TX in structure. I can figure out what values in. I can get a change address, right? Get the pub key, actually, in this case. I can make the transaction output. Start off with max money because this is invalid, so I'm not gonna. This output is invalid for now, but I can go build up the script with the pub key and the check sig. Then I'm building up the op return output, 0 value. Create some transaction outputs, right? Build it into a transaction, and then finally here, well, this is just figuring what fee it should pay. And then finally, I change it from that max money to the value based on the size of the transaction.
This is where it in real life went wrong when the guy mixed the fee.
Yeah, exactly.
The fee with
So for example, in here, if I if I screw this bit up, I could send all my inputs straight to outputs. This is a particularly safe script in that it doesn't check anything after. Like there's no sanity checks on it, but it's just an example. And here I'm using sign raw transaction. That's actually using Bitcoin's transaction sign, with my local wallet. Assert sign raw transaction thinks the transaction complete. It's just getting just the transaction again. And that, And then what was it doing here? I think value in was. Okay. So if it's this is basically just saying if I would need to do another, like if I need another, if like this loop here is just re-signing till I get the size of the transactions right. Because adding signature makes the transaction a bit bigger, so my first attempt at guessing the right fee could be wrong. So I just put in a loop, yeah, until it gets it right, which will complete one or two
Is that why
tries.
most wallets are very bad at predicting, giving you a guess about the transaction fee?
Well, the hard part, right, is, the hardest part is try to find the right number. Here I just hard coded it. So this guess could be completely wrong, but in general, yeah, that's an issue.
Because that's really what was mentioned before.
Yeah.
All these wallets have very small leftovers.
Yeah.
Because you weren't able to
Yeah.
predict.
For timestamping, it's easy because there is only one output that matters, right? It's your change. The other output, zero value, is just putting a timestamp in. And that's really like how this all works. You know, there's a lot to kind of learn to go through it, but yeah, this is kind of the way the example would go.
And then you already executed this before?
Yeah, this has been used quite a bit. I actually use this fairly frequently. This.
But you can run it on the test server now? Or?
Yeah.
So how did it figure out the unspent amount? Because it might need several inputs for.
Well, so this one is kind of dumb. It sorts inputs by largest to smallest, right? So if none of your inputs are big enough alone to pay for it, it'll just break.
It'll just break.
Yeah,
So
yeah.
it's not trying to
Yeah.
find the
I'm
right
not,
amount.
yeah, I'm not trying very hard with this.
Okay.
And if I want to show you it on testnet, I don't actually have Yeah, so in my library, there's a master switch that kind of lets you select what parameters it is, either mainnet, testnet, or array test.
Yeah. So
if I take that, and I put, so if I put that way up at the top here, it's going to be one of the first things we do. So now that I've added that, it'll be up very fast. I'll timestamp itself. There you go. So that's just actual transaction. That's how many bytes it was, and that's the transaction ID. If I then do get raw transaction, so this gets a transaction out of the mempool, or out of the blockchain. Right, that's the same as that. I can ask it to pre-print it. There we go. Input, script, the value of my change, and then finally the top return. And there's no confirmations on this because it's still in the mempool, but if I pretend that I'm a miner, I'll generate a block. Now when I do this, again, it shows more confirmation. And a very useful thing to do to guarantee you can always get transactions is you set your TX or TX index. And that tells Bitcoin keep an index of all transactions that were ever created, just so when I run get raw transaction, the data will be available. Otherwise, get raw transaction fails sometimes because if all the outputs are spent, it just discards the transaction from its index. So
it's back to the summer, isn't it?
but you know, I mean, this library is pretty low level. I mean, it's for instance, C mutable transaction. That is the same data structure that's in Bitcoin. There's no hiding of the details. Like as an example, I think Craig mentioned it. Someone mentioned, op return. Well, if I want to change this to generate, generate transactions that opt into RBF, I can do this at the very lowest level. So that would be transaction input. I tell it.
What does RBF mean?
Replaced by fee.
Sorry?
Replaced by fee.
Oh, okay. Replaced by fee.
And you signal that by setting the sequence on your input to 0. Now that I've added that line of code, All right, now previously, the sequence was set to the default, which is max int. All right, that's, 2 to the 32 minus 1. Now when I do timestamp, if I run this again, I want to go about transaction, sequence is 0. And that's literally the data structure. The CTX_in is this bit of data. Same way as the CTX_out is that bit of data. And transaction as a whole is just this whole thing. I'll give another example. Suppose I were spending simple pay to pub key hash output. All right, like this is your really low level how to spend standard pay to pub key hash output. Go import a whole bunch of stuff from the core data structures, scripts, script evaluation like verify, and some stuff in the wallet. Here I'm selecting mainnet. That's actually creating a secret key, in this case derived by the famous XKCD comic. This is kind of just going through the motions, so I start off with a known transaction ID and output. Create the transaction in. Mutable just means this particular version of the data structure can be changed after the fact. We need to know what the script pub key spending it is for later how the signing works. So I'm just generating that because it would be off2 hash 160, the hash of the pub key, verify check sig. That's the standard script pub key. Create output, we're pretending to sign. That happens to be the same Bitcoin address as that would correspond to. Create an unsigned transaction, input and output. The signature hash, that's the thing that hashes the transaction in the right way, so the signatures expect. This is just what number it is in the flags. And signing it while you're taking your secret key, telling it to sign that hash, and you add some bytes on. And now we set our actual transaction to that signature we generated here, plus the pub key, which is hashed here when you run the script. And then we can verify everything actually worked. Verify, and it all worked. Then we can go print to it for a new serialized transaction. A lot of lines of code, but that's right down to how it actually looks at the lower level. If we run that, okay, that spat out a valid transaction. Decode transaction. That just tells Bitcoin Core, take this serialized transaction, decode it, and print it as an IC or JSON. Now, those are inputs, outputs. That's the signature we calculated. That's the pub key we calculated. That's the value in our new pub key. For example, P2SH approach. Similar kind of idea, but this time we have one more direction because P2SH, we have hash that commits to a script that now has to be run. Yeah, so it's like one, rather than we replace the script pub key with the hash of another script, basically. Go through the detail, but that's kind of like that's a way you can kind of learn how this stuff works. And I find to really get into this detail, the way to do it is really sort of two things. One is actually read the actual code that goes along with this. Here for instance, if this is Bitcoin Core, the main module for all the really core data structures. Got things like, what's the definition of valid money? you know, tuned from hex strings, converting integer money values into readable strings, integer like out points, mutable out points, transaction inputs, and so on. One thing you can do. Where would we be? Yeah, there it proves. It's like some of that stuff corresponds to the right the same name and out point. If you go through like how does this data structure actually work, it corresponds to the same same stuff in my Python library, you know, pretty much one-to-one. Transaction inputs, scripts, and so on.
How does your development environment look like? We see it now. But I say this is the right mix for development. So you of course you use GitHub to pull it. What do you use else? What kind of software?
Vim.
Sorry?
I use very little software. I use Vim and Git.
Vim?
That's basically it. Like by.
Oh, okay.
So, yeah, I don't use any plugins with it other than the stuff it comes with. I mean, I think the only customization I did is I made it like have a color scheme I liked.
Everything command line.
Yeah.
Oh.
Yeah. I mean, keep in mind, like one of my main tools is pen and paper. You know, I work such that most of what I'm doing is like really low-level protocol work and design work, so pen and paper is very useful.
Then afterwards you.
Yeah, this is not a fancy setup.
But then your scripts, they're on GitHub, and then how would one use those? So if you would say they're totally foolproof.
Git clone and you run them. I mean, I don't end up writing much software that really kind of gets released to users. Most of the stuff I write in like Python Bitcoin loops, so test scripts to just test
exactly.
functionality. Like as an example, within Bitcoin itself, you know, this is like our source. This is like all our testing, our unit tests. One is scripts. Like these script tests, I wrote a lot of these, and a lot of the way I write them, particularly some of the more complex ones, like the transaction stuff. Like these are actual transactions. And a lot of these I wrote by writing little fragments of code in Python Bitcoin loop to generate a transaction I thought would test some bit of functionality, signing the signatures in the right ways, and then I then import the result of that into here. Like as an example, yeah, like some of these were developed with that. Yeah, because this generated some Python Bitcoin loop code, serialize the right type of transaction I wanted to check, the right type of check locked and verify case. And all that has to be very low level, but oh yeah, I wrote this stuff. Yeah, this is details how check multi-sig works. And yeah, so like this ugly thing here. Right, that's some convoluted transaction that I wrote basically to test something and check multi-sig. And these signatures, right, were all generated with Python Bitcoin loop. Just writing short fragments of code. You know, I don't. How you would actually deploy that to an end user, I don't know. not my line of work. But Bitcoin J is kind of the same thing where you know, this whole infrastructure for Java programs. That's fairly well tested, but I've never done any of that kind of work.
So I read somewhere that every 2 months or something, the network is calibrated for being able to stick within the 10-minute block.
2 weeks,
2 weeks.
Yeah.
Oh, okay.
Yeah.
So,
2016 blocks.
and who does what after these 2 weeks?
Well, I'll show you the actual code that does that. Where are we?
Why is it necessary? Because you told us before that the target could be manipulated as well.
Well, I mean, that just
By
keeps,
protocol.
well, essentially, if you didn't retarget things,
Mhm.
right? A block right now would take like roughly 1/10 millionth of 10 minutes, right? Because we've grown
Yeah, exactly, yeah.
difficulty up,
Yeah.
so you got to retarget. Like as an example, this is the code that actually does this.
The retargeting.
Yeah.
Okay.
And that just takes index of blocks within Bitcoin, the time of that first block within that set of blocks,
Mhm.
you know, and calculates essentially, well, what work target would be in that, you know, blocks after that point.
Mhm.
And so what's interesting with this stuff is like, if I change any of this code, I mean, it's the definition of valid protocol, so things will break. You know, if I were to change like this to 8, for instance, or actually even worse, 2, right? Somewhere there's blocks, right, where this line of code executes. And if I go from 4 to 2, it'll execute in the wrong way, and it'll just break. And it's the definition of what a valid block is. But in all this stuff, like, if you want to know how it really works, I mean, I would really suggest read through the code.
Yeah.
Go through. Where is it? You can actually follow. Yeah, you can actually go follow set blocks and check block. You can actually follow through the code. You know, that's a thing that checks the block is valid. You know, check that the checker header's valid, check the local root's valid. Check size limits are correct. You know, check the first transaction Coinbase, make just one rule after another. Finally, check each individual transaction. If you follow,
All we need to change is a max block size constant.
yeah, seems so simple. But you know, it's one of those things where it's easy to change things if nobody's trying to exploit the system.
Mm.
You know, if this were normal software, this would be, I mean, for instance, if this were normal software, right, none of this code would be needed. We don't need to check block headers. We don't need to check the work order. It'd be all correct. You know, there's nothing wrong. Nobody's trying to attack you, so you don't need any of this code. It's only, you only need this to guard against dishonesty. You know, when I started like learning Bitcoin, I mean, that's how I approach it. I come to this code, follow through. Well, when I receive a block from peer, what happens next? You can actually find that in function, but there's a function here that processes network messages. There you go. Yeah, process message. So that's a thing that does all the processing of new messages on the peer-to-peer layer. And if you just read through this, I mean, that gives you the sort of hook to everything else that the system does. Particularly like, what is this? So that's like how messages or transactions processed. Well, it's kind of boilerplate, but the important one is set to them pool. And if you follow through that code, all right, what happens next? Go through.
Yeah.
Does it get it to the number pool? Similarly, or is it there? That's the code that processes those blocks. And see here. Yeah, process new block. If you follow what that function does, it'll tell you everything you need to know about how this
Yeah, exactly.
Bitcoin process new blocks.
Where did you make your free switches test environment? Is it, you showed it before.
Oh,
Free switches.
the rig test?
Yeah, exactly, the web test or the actual
Yeah.
network. Is that because if you wouldn't have a switch like that, you would have to keep track of where you are working on? Or?
Well, so the idea behind the switch between like rig test and testnet.
Mm-hmm.
So the way we design these systems is that absolutely everything's identical between testing and mainnet. And that switch at the very top swaps out the set of parameters that make the difference between testing and mainnet. As an example, like what's the gen symbol, right? The difference between the two. And we want none of the codes depend on that difference except the one little thing that swaps everything over.
But that's dangerous too, because if you...
Well, it's safer than making them different, right? Like suppose you had two separate binaries for testing and mainnet. Well, if there's a bug that affects one but not the other, your testing isn't going to work properly. So you want absolutely everything identical, except the thing that determines whether it's real money or not. The more stuff that you change between the two different networks, the less likely it is for your test to cover errors on one. That's why it's like a command line flag here.
So it's not a precaution measure.
Yeah.
You might make a mistake when you develop.
Yeah, no, I mean, I personally, the way I develop tends to be, I do all my testing on mainnet with real money, and then I just don't put in more money than I can afford to lose.
Okay.
And if I'm getting paid X amount per hour and I'm putting in $5 worth of Bitcoins, like, who cares?
Yeah.
If I screw up, I'm at $5, I really don't care.
Yeah.
And I don't actually screw up that often, so I've probably lost like $100 worth of Bitcoins by screwing up the testing. And when you consider like how many dollars worth of work that $100 was lost in, it's completely meaningless.
Why do you test on mainnet? Testing?
Because I find it forces you to go think harder about what you're doing because there's a bit at stake.
All right. Okay.
Whereas the other tests I do, which are like automated testing, that all it's done on rate test, which is the test network where you just set it up.
So what's the difference between testnet and reg test?
So testnet is a public testing network,
Okay.
right? Everyone
Right. Okay.
has
Oh,
access to testing.
Yeah, reg
And
test.
that's mainly useful. Like if I want to test something between, say, my phone and my computer, well, rate test only exists on my computer, whereas testnet, my phone can connect to.
Okay.
The other thing with testnet is like really extreme network events happen all the time. People reorganize thousands of blocks and so on. So if you want to know that your software is robust, try it on testnet and see if you can go.
I wanted to say that the lunch is ready. You can just go into the room over here and just grab a plate and what you want, and then sit down where you want.
Nice. Yeah, that's great. Thanks.
No, thanks, Peter.
Yeah.
Sorry for the stupid question.
They're a lot less stupid when you think, how the hell would you have found the answer to them?